Hi, welcome to week 3 of quarter 4. This is the last week of this unit, so what that means, you've heard me say it before, everything from week 1, 2, and 3 is due when? Friday at midnight. So next Friday at midnight, you need to have everything from week 1, week 2, and week 3 turned in. And yeah, so let's get started on our last example. This example is kind of different than some of the other examples that we've seen, and we'll see why in just a minute. So this question is about something kind of maybe a little silly. It's about concrete and bridges and highways. So bridges on highways often have what are called expansion joints, and they're small gaps in the roadway between one bridge section and the next. So when you're on a highway or on a bridge, you might be driving and hear a gunk 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 gunk. And you put gaps in cement in order to allow them to expand and contract depending on if it's cold or if it's hot. In Minnesota, we have big swings in temperature. Well, on bridges, they do that to the extreme. And so these are called expansion joints. They allow the concrete to come together and separate as the temperature changes. And that way, you don't get as many cracks in your concrete and the bridges last longer. Okay, the gaps are put there so the bridge will have room to expand when the weather gets hot. Suppose a bridge has a gap of 1.3 centimeters when the temperature is 22 degrees Celsius. So this will not happen in any other problems that are brought to you in this unit, but it's important to understand that sometimes information might be given to you in an order that you're not used to. In this case, you need to think about what is in control. So the temperature actually controls the size of the concrete and if it's expanding or contracting. And so it controls how big the gap is. So in this case, our coordinates are actually going to be flipped. Now, again, this is not something that you normally really need to worry about. It won't come up again in any other problems, so that's nice. But, us math teachers, we just want to make sure that you have seen an example where you might have to think about this, that you have to think, okay, what is controlling things? And the X controls the Y. The other thing that tells you this is it says assume gap width varies linearly with the temperature. So that means the gap width is being controlled by the temperature. All right, so we're going to go through our questions. All of the questions are always the same. Remember, represents means what are the X units? What the X coordinate represents degrees in Celsius. The Y coordinate represents, what does the Y coordinate mean? It means the width of the gap, which is in centimeters. All right, next part, calculate the equation of a line. Let's do it. We know that when we need to find the equation of a line, we start by going y equals blank, x plus blank. We know that we need to fill in those blanks. The first blank is going to be the slope. Subtracting the y's on top and the x's on the bottom. So 0.9 minus 1.3 on the top. And then 30 minus 22 on the bottom. Now, if you want to do this by hand, you're more than welcome to do that. 0.9 minus 1.3. As you all know, I am epic lazy person, so I'm going to do it on the calculator. There we go. We got our decimal. Now, I could change this to a fraction. I'm going to use a fraction because I think it's really a lot easier to interpret the slope later if we use a fraction. All right, second thing we need to do is solve for the b. Let's do it. Writing down y equals mx plus b. And then we know that the slope was -1 over 20. And we're going to use our first point because I'm boring. And I always use the first point for the y and the x. All right, 1.3 is equal to -1 over 20 times 22 plus b. Remember, multiply those two numbers before you go any further in your solving. You could always practice your mental math skills here, but using the calculator is great also. So it's -1.1. I'm going to leave that one as a decimal. We just really like to have our slope as a decimal because that'll make this question later a lot easier. All right, and then now we solve for b. We have -1.11s. We want to create a 0 there so that, oops, I wrote 1.1 here, but it should be 1.3. All right, adding top to bottom, we get 2.4, created a 0, is equal to b. And we know that the b value is 2.4, so I'm going to put 2.4 there. So something that comes up in my mind as a mathematician is that I feel like you should have to pick one. Pick decimals or pick a fraction and stick with it for the whole problem. For this case, I'm going to break that rule and I'm going to just leave it like this. All right, so the first question is, what is the y-intercept? Well, we know the y-intercept is the b value, so we could say it's 2.4. But we need to interpret it. What does it represent in this problem? What does the y-intercept represent? And it is the starting amount. So that can be kind of confusing, but I think it's more important to go back and think about all the definitions of the y-intercept for this. And we know that one of the definitions is that it's when x is equal to 0. So if x is equal to 0 in this problem, that means that we are at 0 degrees Celsius, which is actually freezing in Fahrenheit. So for us, this is 32 degrees Fahrenheit. So what this is saying is that if you are freezing, right, if it's freezing temperature outside, the gap in the bridge will be 2.4 centimeters. And there's so many different ways to say this, but I'm going to say when it is 0 degrees Celsius, the gap is 2.4 centimeters, which makes sense. If it gets colder, the gap gets bigger because the concrete gets smaller, and so it pulls apart, so that gap is going to get bigger. All right, let's take a look at this next one. It says, what is the slope of our equation? Boom, we got it. -1 over 20. And then what does it represent in this problem? Well, remember, it's the y unit. So the y unit is centimeters over the x unit, which is the degrees Celsius. And so remember, we need to kind of think through this, but it's -1 centimeter, so going down 1 centimeter for every or per 20 degrees Celsius. So I would say the gap gets 1 centimeter smaller, right? So the gap is getting smaller, which means the concrete is expanding to make the gap smaller when the temperature raises 20 degrees Celsius. This is a tricky problem. I think this is probably the toughest problem out of all the problems in this whole unit. So if you're having a little bit of trouble interpreting these answers, it's okay. Like I said, these are the trickiest. This is the trickiest problem out of all the problems, I think. All right. So x-intercept of this scenario, remember x-intercept is when we solve this equation. And we know that this equation for our problem looks like this. And we're going to solve it. It's just a two-step equation, so you always add or subtract first, creating a 0 there, adding from top to bottom. Negative 2.4 is equal to negative 1 over 20x. And then we're going to divide both sides by negative 1 over 20. If you want to use one of those tricks that we talked about before where you flip the fraction and multiply, feel free. For now, I'm just going to do this the boring way where I just put it into the calculator exactly like how we have it, and we get 48 is equal to x. All right, and then the second part of this question is, what does the x-intercept represent in the real world? So remember, x, the unit for x is degrees Celsius, and 0 is the y-intercept, the y value. So the y value is in centimeters. So at 0 centimeters, that means that the gap is no longer there. There's no more gap. So it's kind of like an ending point, but in this problem, got to think a little bit harder. So we could say at 48 degrees Celsius, the gap has closed, right? There's no more gap. Kind of like an ending point, but a little bit different in this scenario. Okay, how wide will the gap be at negative 10 degrees Celsius? So remember, this is an x value, and it says how wide. That's a y value. So we need to replace the x with negative 10. And solve for the y. Lucky for us, this should be pretty easy because y is already solved for. Y is already alone on one side of the equal sign. Cheater, pumpkin eater, that's me. We are going to put this whole thing into our calculator all at once as to not make any mistakes. And our answer is 2.9, and that's the y, so it's 2.9 centimeters. And so it doesn't say what does this represent in real life, but I want to make sure we understand that this is going to be when the temperature, I'm lazy, is negative 10 degrees Celsius, which is pretty cold, right, below freezing. The gap will be 2.9 centimeters wide. 2.9 centimeters. Okay, the next one, it says at what temperature, so that's our x, that's what the question is asking you to solve for, will the gap only be 0.5 centimeters, so that's our y, that's our y, so we're solving for x and we're given y. So our equation, y equals mx plus b, we know that y is 0.5. The m we get from our equation, x is what we're solving for, and we know our b. All right, we're going to solve this. All right, sorry, I had a little bit of a technical difficulty there, but here is the answer to part H. All the steps are there. So go ahead and check your answer with me, and we're going to go on to the part where we put everything into Desmos. So I saw a lot of students were struggling with this. Click the wrench in the corner to put this information into Desmos. And then the part there is down here where it says x-axis. That's where you're going to put in all that information. And then you're going to put the equation from part C, the points from part A, in there, and then go ahead and get rid of that, take a screenshot and enter it into your notability notes. Something I also noticed as a common mistake is that a lot of students were putting in this times button, which gives you a dot. We want to use this X button. Even though they look the same, they're not. All right, good luck, you guys. As you know, I always have our study session on Fridays at noon in FJ Office 10. I hope to see you there. Good luck!